Okay, good afternoon, ladies and gentlemen, to another installment in 8-hour chemistry, year 11 8-hour chemistry. Today we start solutions, and uh, we'll be starting off with the difference between a solute and solvent. Uh, Before I start defining it, I think I should give you some time to discuss this and share with me what you know about it already. So I'll give you a minute to have a discussion. I want an example of a solute, an example of a solvent, and let's add throw solutions in it as well. How does that fit in? So difference between solute, solvent, and solutions, as well as examples of each. So could you just give me that in the next 1 minute? Thanks. Okay, so on discussion with the students, we learned that a solution is actually a mixture of two or more substances in a single phase. And so, for instance, if you have two gases mixed together, as long as it results in the single phase, that is a gas, it will be a solution. So, carbon dioxide mixed with oxygen, it's a single phase. The resultant phase is a single phase. That means uh, it is a solution. Uh, Another example would be uh, a salad dressing, which is a solution because the resultant phase is uh, a liquid. But salads, a salad is not a well, is a mixture. Is a heterogeneous mixture. So a solute has both a solvent and a solute. And how do we define the solvent and the solute? Okay, just a sec. Yeah. So a solute is the part of the solution that actually dissolves in the solution. The solvent is what dissolves it, and it is usually the one in greater amount. And finally, the solution is defined as a solute plus a solvent. Now, what I'm asking the students to do now is to write down examples for a solid-solid mixture, a solid-liquid mixture, a solid-liquid solution, a gas-solid solution, a liquid-liquid solution, a gas-liquid solution, and a gas-gas solution. So I'll give you some time to think about it, and then we'll start discussing. Okay. So the example for a solid and solid was an alloy. And the example for solid as a solute, liquid as a solvent is salt and water. Gas as a solute, solid as a solvent would be palladium or platinum metal absorbing hydrogen gas. Liquid as a solute, liquid as a solvent would be cordial in water or ethanol or alcohol in water. Gas as a solute and liquid as a solvent is carbonated drinks, acidic carbonated drinks. Gas and gas would be air. So now moving on to the next bit, we're going to talk about the difference between saturated. Actually, I'll move on to solubility before I move on to the difference between saturated, unsaturated, and supersaturated compounds. So, just a sec. Okay, so now we move on to solubility rules, and I just discussed with the students that solubility is just the mass that can dissolve, mass of a solute that can dissolve in 100 grams of water. And now we are talking about figure 2 in your textbook, which is page 135. And my question from figure 2 is, stick. My question is, what is your observation by looking at the curves in figure 2? What can you tell me about? What do you observe? What do you think? What are your questions? So have a look through figure 2 and tell me what did you observe. Okay, if you had a look at figure 2, you would have found that the independent variable is temperature, while the dependent variable is solubility. And you would have noticed that for every salt, as you increase the temperature, the solubility goes up. But with the exception of cesium sulfate. Cesium sulfate actually shows a decrease in solubility as you increase the temperature. However, if you notice what happens to HCl and NH3, as you increase the temperature, the solubility decreases. Now, what I want you to do is to think about, in addition to practicing question 1 and 2, what I want you to do is think about real life implications of a decreasing solubility with an increase in temperature, a real life implication of it. So just and we'll discuss that in a minute. Okay, so very quickly I wanted to go through the definitions of saturated, unsaturated, and supersaturated. Now, although the formal definitions are already in the textbook, I'll go through an example which makes it really clear what each is. So unsaturated is, let's say you had a glass of water and you were to add NaCl into it, salt into it. And when you added those teaspoons of salt, they readily dissolved in the water. NaCl readily dissolved. That means that the solution is unsaturated. That means it is still capable of dissolving salt. Unsaturated. The second case is saturated. That means that you dissolve the salt, you try to dissolve the salt, but you reach a point where some of the salt actually settles at the bottom of the glass. And that's where you know that the solution is saturated, it can't take any more. Saturated or full of solute. Not capable dissolving more. Capable of dissolving anymore. However, you can dissolve more if you change the temperature, because we just learned from solubility curves that the solubility of a solid salt is a function of its temperature. You increase the temperature by pouring it in, let's say, this container, and you heat it. If you heat it, now that salt that the salt at the bottom that we talked about will magically, well, not magically, it's because of the temperature, it'll disappear. And now this is a supersaturated solution because you have just added more than it could take. More salt because of, now this is for because, by the way, that 3 dots, because of high temperature. Okie dokie. Now that should make you a little bit comfortable doing question 2, was it? Yeah, question 2. Okay, we move on to the next bit, which is the difference between dissociation, ionization, and partial ionization. I have 3 reactions written down, and they're the same from the book, but I just want you to look at these 3 reactions and tell me what the difference between each of them is. It's a more like a see, think, wonder exercise. What's the difference between each one of them? And try to give me a difference or write a difference between dissociation, ionization, and partial ionization by looking at these equations above.